Okay, so for my video presentation for microbiology, I have chosen to do the citric acid cycle, which is also commonly referred to as the Krebs cycle. So before beginning the Krebs cycle, it's important to know the products produced in glycolysis. So in glycolysis, we have 2 ATP produced, 2 pyruvates produced, and 2 NADHs. These 2 NADHs will be transferred to the electron transport chain, where their electrons will be used to power ATP synthase to create more ATP molecules for energy. But these 2 pyruvate molecules will be transferred to the mitochondria, where they will take place in a process known as the Krebs cycle. And as soon as these pyruvates enter the Krebs cycle, they must, or before they enter the Krebs cycle, it's kind of like a preliminary stage that they must go through to be broken down. It's also known as pyruvate dehydrogenase and the pyruvate shunt. So in this process, the 3-carbon pyruvate will be broken down by pyruvate dehydrogenase, and while it's being broken down, it will produce a NADH molecule, and one of the carbon molecules from the pyruvate will be bonded to an oxygen atom and create carbon dioxide. And this carbon dioxide will then be released back into the environment through respiration. So the 2 carbon molecule that's left here in after the CO2 is bonded to the oxygen is known as acetyl-CoA. So once acetyl-CoA has been obtained, it can then be transferred into the Krebs cycle. And what starts this process is the acetyl-CoA will come into the Krebs cycle and bond with a 4-carbon oxaloacetate, creating a 6-carbon citrate. And a citrate is a common acid that we find in lemonade, orange juices. It's an everyday thing that we see on breakfast time, whenever you like orange juice or lemonade, I guess, but your mimosas. But next, it goes through several processes to reform oxaloacetate to restart the cycle again, which an acetyl-CoA will come back and bond with the oxaloacetate, and it will just keep on turning. But after obtaining citrate, it will come into encounter with another molecule known as cis-aconitate, and cis-aconitate will then reduce citrate into isocitrate, and isocitrate will then be reduced by oxalosuccinate, and once this reduction has occurred, it will produce NADH and a CO2 molecule. So then it will be transformed into alpha-ketoglutarate. Alpha-ketoglutarate will then be reduced with alpha-ketoglutarate dehydrogenase, and once this happens, it will release another NADH molecule and another CO2 molecule and form succinyl-CoA. So then succinyl-CoA will be reduced by succinyl-CoA synthetase and produce GTP. And once this GTP has been released, it will form succinate. Succinate will then be reduced by succinate dehydrogenase to form fumarate, and during this reduction, an FADH molecule will be released. So then fumarate will be reduced with fumarase to create malate, and nothing is produced during this step of the cycle. And then malate will be reduced into oxaloacetate with a malate dehydrogenase enzyme, and during this reduction it will produce another NADH molecule. And then the oxaloacetate will bind to another acetyl-CoA coming into the cycle, and the cycle will be repeated. So an easy way for me to remember all these steps of this process is an acronym that I like to. It may not be appropriate for some classes, but it helps me to remember it. It is can Atom intrigue a super sexy foxy mama? Okay. And it's can is citrate, atom is cis-aconitate, intrigue is isocitrate, alpha-ketoglutarate, super succinyl-CoA, sexy, succinate, foxy is fumarate, mama is malate, and OK is oxaloacetate. And that's just an easy way for me to remember it, and I always remember that oxaloacetate bonding with acetyl-CoA begins the cycle. So one thing we need to take out of looking at this is the number of NADHs and FADHs that are produced, because each of these will be transferred to the electron transport chain so that their electrons can be used to power ATP synthase and produce ATP. Also, there are two pyruvate molecules produced in glycolysis. So, knowing this, we can say that this process will occur twice because as glycolysis occurs, it will release two pyruvates into the mitochondria simultaneously. So, these two pyruvate molecules will need to go and undergo this process pretty much at the same time, which will mean that each of these products will be doubled. So here we see that we have 1, 2, 3 NADHs just from the Kreb cycle, but we have to remember that in the prior step we had one NADH formed as well. So for this one pyruvate molecule in this process, we have that one in the pyruvate shunt, one here from isocitrate to alpha ketoglutarate, one here and one here. So that makes 4 in total for one pyruvate molecule. Well, since we know that is doubled, we're going to go ahead and say that we have 8 NADHs produced. Well, then looking at ATP, well, another word that we know for ATP is GTP, and we see here for one pyruvate molecule we have one GTP produced with no other ones around. So we know that can be doubled for each process, so we know that that'll be 2 ATP produced. Next, we look at FADHs. And in this cycle, we see that we have 1 FADH produced for 1 pyruvate. So that means per Kreb cycle, or per cycle of the Kreb cycle, we will have 2 FADHs produced. So what we need to do with this information is combine the two. Combining the Kreb cycle and glycolysis, we see that we have 4 ATP in total produced, and we see that we have 10 ADH produced and 2 FADH. Well, in cellular respiration, there are 3 steps, and the first 2 steps are glycolysis and the Kreb cycle. Well, what predicts the outcome of this last step is the amount of NADH and FADH that are produced in these first 2 cycles. So these NADHs and FADHs will be transferred into the electron transport chain, and NADH molecules produce 3 ATP per molecule. So knowing that an organism has produced 10 NADHs after combining these 2 cycles, we can say that they will produce 30 ATP in 1 cycle of the electron transport chain just from these NADH molecules. Well, then we have to look at FADH. FADH molecules produce 2 ATP per molecule in the electron transport chain. Well, we know that we have 2 FADHs produced from these 2 cycles, and we could say that FADH will produce 4 ATP molecules in total from the electron transport chain. So we have 30 ATP from NADH and 4 ATP from FADH and 4 ATP from glycolysis and the Krebs cycle. So combining all those together, we will get a total number of ATP that is produced during cellular respiration as 38 ATP. I hope you enjoyed this presentation.